Hi, I'm Cassie, and I'm going to walk you through question 51 of the AAMC's official physics question pack to help you prep for the MCAT. So this question is about understanding what a diverging lens does. And the answer is actually really straightforward. We're asked what the diverging lens does. Well, it's going to diverge rays. So for me, that's answer choice D, diverging rays. But again, this question is unusually easy for a question written by the AAMC. A more typical question might have been written asking what a concave lens does, like the concave lens that is shown to us in the figure. And then you might have had a harder time trying to remember, wait, does a concave lens diverge rays or does it converge rays? Compared to the fact that they just told you it was a diverging lens, so you knew it diverged rays. So let's make sure you're prepped, not just to get this question right, but to get other more realistic, harder MCAT questions right about lenses or mirrors. So first of all, what's the difference between a lens and a mirror? Well, we know that mirrors reflect light. So a light ray is going to hit a mirror and it's going to bounce back off. And remember, according to the law of reflection, the angle of incidence on the mirror equals the angle of reflection off of the mirror. And then compared to that though, lenses, like think about contact lenses. If the light just hit our contact lenses and then bounced back off, that wouldn't be very helpful, right? We need the light to get through the lenses and into our eyes. So that's the main difference between mirrors and lenses. Mirrors reflect light back off of it, and lenses refract or bend light and let the light go through them. So that understanding of the basic difference between mirrors and lenses is going to help you remember the differences between them. So let's start with mirrors because they're a little more straightforward. So let's start by talking about a concave mirror. Well, how are we going to draw that? Concave, remember, is like a cave. It's going to cave in. So you could draw a concave mirror like this. And is a concave mirror, is it going to converge rays of light or is it going to diverge rays of light? Well, let's think about it. Well, let's say we have a ray coming parallel, a ray of light, and it hits our concave mirror. What's going to happen? How is it going to reflect? Well, given the fact that our mirror is curved in, when it hits that mirror, that ray is going to reflect inwards. Now, vice versa, if we had a parallel ray coming here, then again, given the shape of the mirror, that ray is going to converge inwards. So that just means our focal point for our mirror is here somewhere in front of the mirror. So that tells us that a concave mirror is going to converge rays of light. I'm going to write that up here, converging. Now, what about a convex mirror? Well, a convex mirror is going to be the opposite of a concave mirror. So if you think of a concave mirror like the inside of a spoon, a convex mirror is like the outside of a spoon. So if we have our same parallel light rays, and again, I should have drawn arrows here to indicate our light rays. So if we have our light rays traveling in this direction, when they hit that convex mirror, that back of the spoon, given the shape, they're going to reflect out this way. Likewise, if we had a parallel ray coming in this way, it's going to reflect out this way. So is that converging or diverging? That's going to be diverging. So let's go ahead and write that here. A convex mirror is going to be diverging. Now let's think about lenses. So first, let's think about a convex lens. So the easiest way to remember for me what a convex versus a concave lens does is the fact that it's just going to be the opposite of concave and convex mirrors. So whereas a concave mirror is going to converge rays in, a convex lens is going to converge those rays in. So if you can just remember which kind of mirror converges rays, you can easily remember that the opposite types of lens is going to converge those rays. So remember our lens here, our convex lens is going to have two sides instead of just the one side. We've got to draw its 3D shape. And again, we know that our light here, instead of reflecting off of the lens when it hits it, is going to be refracted through that lens and ultimately go through the other side of the lens. So if I were to draw one of my parallel rays here hitting our convex lens, it's just going to, again, converge. So it's going to converge on the other side of the lens. Same thing here, it would just converge on the other side of the lens. So our focal point is going to be on the opposite side of the lens here. Now, what about our concave lenses? Well, since we know that they do the opposite of our mirrors, we know that while our concave mirror is going to be converging, our concave lens is going to be diverging. So again, we can draw that concave lens. It's got to go in on both sides, like the inside of a spoon. And what's going to happen is our light ray is going to travel here. It's going to hit our concave lens, and it's going to be diverged outwards. It's going to go through our lens and it's going to be diverged outwards. So that's how you can remember what kinds of lens and what kind of mirror does what. But my drawings of our lenses here are actually a bit of a simplification because remember what's happening with our lenses is refraction. So we have our light rays here that are traveling through air, and then all of a sudden they enter into our lens, and that's going to be a different medium, a more dense medium. So they're going to get bent when they enter into that lens, and they're also going to bend again when the light ray then comes out of the lens. So if you want a more accurate picture of how that bending is actually working, how that convex lens is actually converging those rays, let me show you now. So starting with our convex converging lens here, let's go ahead and draw it nice and big so we can actually see that refraction happening. So here's my giant convex lens. So what's going to happen? Well, so what's going to happen with my light rays here? How are they going to bend? So let's say I have my light ray again, and it's coming in to hit my lens like this. So how is that light ray going to bend? When it goes from a less dense medium, so when it goes again from air into the lens, and then how is it going to bend again when it goes back into air? We know that whenever we're doing Snell's law problems, we need to draw our normal, and our normal needs to be perpendicular to our surface. So I'm going to draw our normal here perpendicular to my lens surface. So if my normal is here, where is going to be my incident angle? Well, my theta I, my incident angle, is going to be here. And then we know, according to the mnemonic, remember FST, we've covered in previous questions, that when we go from a medium where air is traveling fast with a lower index of refraction, like air, where we know the index of refraction is 1, into a medium that has a higher index of refraction, like a lens is more dense than air. So when we go from a medium where light travels fast to a medium where light travels slow, then we're going to bend towards the normal, T for towards the normal. So that means my light ray, my second angle here is actually going to be smaller, because we're bending towards the normal. So that's my light ray, again, getting bent. So my second angle, my angle of refraction, my theta R, is going to be less than my theta I here, right? Theta R is less than my theta I because we bent towards the normal. Okay, so that checks out so far with the facts that we talked about. Convex lenses converge light inwards. But then let's see what happens when that ray of light then leaves our lens. So if we continue our light ray coming here, we're going to hit our surface again, and let's go ahead and draw our normal again for our surface. Is going to be something like that. So our angle of incidence is going to be here. We're going to call this again our theta I, and then our angle of refraction is going to be, well, here we're making the opposite transition, right? We're going from more dense to less dense. So instead of bending towards the normal, we're going to bend away from the normal. So that's going to look something like this, where again, here, our theta R is going to be greater than our theta I. So notice again that this picture is not perfect, but ultimately what's happening with our ray, even though it's bending twice, its trend is it's getting converged, right? It's not getting diverged. And so I'll go ahead and erase my ugly looking picture here and replace it with a picture that's a little neater. And you can pause the video and take a look if you need to. Okay, so now let's go ahead and let's draw what happens. So now let's go ahead and let's do the same thing. Let's look at how the refraction works for a concave lens that is going to diverge our rays. So we're going to draw our concave lens a lot bigger so that we can see it better. Okay, and now we're going to have our perpendicular ray come in here. And let's go ahead and let's draw our normal line to the surface of our lens. So our normal would be something like this if we're going perpendicular to our surface. So again, where our angle is going to be, well, our incident angle is going to be here. We're going to bend going from lower density air into a higher optical density lens. So we're going to bend towards the normal. So our angle of refraction is going to be smaller than our angle of incidence. So again, it's going to get closer to our normal line here. So that means that, so our angle of refraction is this here, theta R. And we know again that theta R is going to be less than our theta I. And then that light ray is going to continue through until it again hits the other side of our lens. And let's go ahead and draw the normal line for the other side of our lens. Would be something like this. So now we're making the opposite transition, more dense to less dense. So we're going to bend away from our normal. So that means we're going to bend something like that. And again, so our angle of incidence was right here, and our angle of refraction is going to be bigger in this case, and it's going to be right here. We see that that transition ultimately makes a pattern where we entered the lens and we diverge out. So again, I'm going to replace my messy hand-drawn diagram. Okay, so now we got our neater diagram here. So I hope this helps, because I know when I first came across the concepts of mirrors and lenses, I was a little confused on how to figure out what was diverging and what was converging. So just to sum things up here for our takeaways, always start with mirrors and think about the fact that the shape of a concave mirror is naturally going to converge light rays in. So concave mirror is converging. Then we know if a concave mirror is converging, the opposite kind of lens is going to be converging. So our convex lens here is going to be converging. And then when we think about diverging, well, we know our convex mirror is going to be diverging because, again, the shape of the lens is just going to diverge those rays out. And if a convex mirror is diverging, then we know the opposite kind of lens must be diverging. So a concave lens is going to be diverging. So make sure you can not only remember that, but you also understand with the lenses that you're actually getting 2 points of refraction here. You're getting a point of refraction when the light enters the lens, and then again, you're getting another type of refraction when the light exits the lens. And try and draw these diagrams here on your own so you can get practice with drawing the normal perpendicular to your surface when it's not just a flat surface, because it can be a little tricky at first to see what's going on. But I've seen many different MCAT questions that sort of test your ability to understand this concept. So I hope this helps you understand it. If this helps, please like this video and follow my channel for more content like this.